So first, who's used Kubernetes or played with Kubernetes before? All right, who knows how to spell Kubernetes? All right, we'll learn that too, so don't worry. You'll get it down. All right, so where we're starting is first, that's me. And then this is Kubernetes. You can find it at kubernetes.io. And it's Kuber and then Netes. What we're going to be going through is this official Kubernetes on CoreOS guides that we recently released. This was the blog post that did it. But if you're actually trying to find it somewhere, click up in this docs section on CoreOS.com. And then we'll scroll down a little bit. And we'll scroll down. Oh, I passed it. Too fast. What happened? Oh, there we go. And what we're going to be looking at here is clicking here, view all CoreOS documentation. And then we're going to be looking in particular at this single machine Vagrant cluster. This is because you never trust Wi-Fi anywhere else. And so running on Vagrant is the right choice. So what we'll do with this single machine CoreOS cluster is first, if you have Vagrant on your laptop, does everyone have Vagrant on their laptop for the most part? OK. It's pretty easy to install. Go to vagrantup.com. OS X, Linux, et cetera. You'll get that all set up on your laptop. We'll download the kubectl command line tool. Really stretching out this HDMI cable. And so once we get the kubectl tool installed, we should be able to type kubectl into the terminal of our laptop. And that should work. And then we'll download the CoreOS Kubernetes Git repo. So I just happen to conveniently have planned ahead, and I have a copy of that checked out in my home directory. And then finally, we'll run Vagrant up to actually spin it up. So here I am in the repo, and I type Vagrant up, and Vagrant's going to go through its process to tell me that it's currently running. Fabulous. Okay, so the next piece, now that we have a cluster up and running, what this does is actually downloads all the Kubernetes components and spins up a single machine cluster. So we download all these components in containers, obviously, and then those things start to expose an API endpoint. Then we'll configure the kubectl command line tool on our laptop. This configuration essentially sets the IP address of our Vagrant machine and then points it at the private or the public key of the Kubernetes cluster, because we built TLS certificates when we did Vagrant up for this cluster, so that we're talking over a secure channel. And then we just start using that by doing kubectl set context. So if all things worked and my cluster is continuing to run, I should be able to do kubectl get nodes. People see that? Make it bigger, bigify, or big. And so we will have a single machine Kubernetes cluster. So there's the machine on my laptop is acting as both the API endpoint and the scheduler, and then also acting as a place that work can be scheduled to. All right, everyone on board so far? Makes sense? Questions? All right. So now that we have Kubernetes up and running and it's all working OK, we'll want to actually deploy an application. So there's a link here at the bottom of this Getting Started guide that says, let's go view the guestbook example on kubernetes.io. I'll close this tab. And on kubernetes.io, it has this really long process where it talks about how to deploy this 3-tier app. So this app is going to have a Redis master as its primary data store, a couple of Redis replicas, and then the actual guest, I guess it's a 2-tier app, and then the actual guestbook application, which is a standard HTTP JavaScript application. So it's going to walk through kind of how this thing's built, what are the objects inside of Kubernetes, services, replication controllers, et cetera. But very impatient here. So what we're going to do instead is walk over, where is it? So I have a checkout of the Kubernetes code base. So this is github.com/Kubernetes. And inside the example folders, we find this guestbook go thing, which is the application we're about to deploy. And inside of that are a few JSON files. And those JSON files walk through how this application is actually deployed. So let's open up one of these files. This is the service, and so this service defines how to find all the copies of the guestbook application that are running and then put them behind a load balancer. All right? So the things that are in here are things like this load balancer is going to select all of the things that say that are app guestbook. It's going to put them behind a node port, in this case 30,002. We'll talk about what that is in a second. And essentially just set up this load balancer. And the other objects are the actual guestbook replication controller, which says we're going to be running this this image, this container image. We're going to be telling that container image to listen on port 3000, et cetera. All right. So for making it a lot easier, what we'll do is we'll have a for loop that just goes through these JSON files and deploys them to the cluster. So we'll see the replication controllers and services, et cetera, are going. And then we can just watch that those things are actually deploying. So we'll see that some of them are in pending state. They're downloading, they're getting running. Oh no, I ran out of memory on my Vagrant machine. Perfect timing. And so, yay. Even though I ran out of memory, it still deployed enough of the containers, and it would actually run the application. So let's see how many of those actually got deployed. OK, they all got deployed. Perfect. Transient error. So what we're doing here is we're actually hitting the endpoint that the guestbook service is running on. And so this is 30,002. And we can refresh, see that the application is running, type things into the guestbook. Of course, you're going to get lots of useful information if you actually ran this service like spam. And so this is me getting up and running a basic web application on top of Kubernetes in just a few seconds. Now, what I also wanted to show off was we have a commercial product that's built on top of Kubernetes called Tectonic. And one thing that's kind of nice about Tectonic is that we have a dashboard that kind of lets you introspect what's happening in the cluster. And so if we look in here, we actually see the objects of the guestbook replication controller, and we can see the running versions of the application inside the cluster. And one kind of fun, interesting thing is that we'll go in here, and what this is doing is we're going to write the classic load testing script that we've all done. While true, run a curl script. And what we're going to do here is look at this JSON file that the guestbook service exposes. So if we go in here, they have this little link here, said environment. And inside this environment, there's a host name. And this host name is the unique host name of the instance that's actually serving up this JSON. So if we run this in a curl loop, we'll see that we're actually getting a bunch of different random copies of this. This is showing that the load balancing is actually working. And so to kind of just show off, the dashboard doing its thing, we'll go in here and we'll lower the number of copies of the application running from 3 to 1, and then click update desired state. What should happen is, is that all those copies of the guestbook went away, and that we only have one copy that's actually presenting. Who wants to guess what will happen once I lower this to 0? Anyone? And so you can kind of scale up and down the application behind the load balancer at will. And it's really what this boils down to is it's thinking about applications in a way whereby scaling is actually just dragging a slider. So what we should see here is that in a few seconds, once curl times out, we start to get instances of the application up and running again. And we're seeing instances that have never ran before. All right? So this is my quick talk. What you all are getting right now is homework. So what I'd ask you all to do is to go onto the CoreOS docs and try getting this all up and running. It will be just ever so slightly slower if you're using Comcast at home. But it's a great way to kind of figure out and learn about these technologies. And the neat thing is that we provide guides that take you from this single node cluster, talk through running a multi-machine cluster on your laptop, and then eventually instructions on how to actually deploy this sort of stuff on bare metal or on AWS, et cetera. So it's something that you can take these same concepts of how these applications are deployed and put together and scale from your laptop up to actual production systems. So with that, I'm going to end my talk, and thank you for your attention. And I'll answer any questions if you'd like. Thank you. Yep.
Well, you quickly told you can actually run Kubernetes on CoreOS on bare metal.
Yeah. Yeah, so the question was if you can run Kubernetes on CoreOS on bare metal. And essentially what happens is we run these components just inside of containers. So you run a CoreOS machine, and then the API endpoint and the schedulers, et cetera, run inside of containers on those hosts. And so we walk through actually bringing that up just manually. So walk you through every single step of set up your network this way, now set up the control cluster this way, set up etcd this way. Now tell your worker machines with these TLS certs to talk to this control plane and that sort of thing. Yep. Yes?
How would you compare Tectonic to OpenShift?
Yeah, so how do you compare Tectonic to OpenShift? OpenShift is a platform as a service that comes out of Red Hat. So Tectonic is kind of this place that's between a PaaS and like infrastructure as a service. So we think of infrastructure as a service as I get physical machines delegated to me from IT in a faster way. So I can click and click and click, and I get 4 or 5 VMs or whatever on this sort of network with this sort of disk. And then platform as a service is I do get push, and then suddenly I am behind a load balancer, and that application is actually deployed for me. So somewhere in the middle is this thing where for whatever reason, a variety of reasons, my application isn't as simple as like get push and it's behind a load balancer. I actually need to think about the architecture of my application, what is the rolling upgrade process, et cetera. So it can be used in a lot of cases to build PaaSes, but also, I mean, all of us have kind of been in that environment where we spend weeks, probably months of our time on an application, not actually worrying about the application, but the life cycle of the application of, all right, so we have version A of the app and version B. Now we need to roll out version B. How do we do that? How do we control that life cycle? And that's kind of where Kubernetes and Tectonic sit, is automating away a lot of the stuff. We have a lot of bespoke software around in a lot of these web applications. Yep. Yeah.
How do you compare Tectonic with Mesosphere?
Yeah, so how do you compare Tectonic to Mesosphere? Tectonic is a pure Kubernetes platform, and so we directly use just pure Kubernetes stuff. So we use the Kubernetes scheduler, and we focus very much on that tier of application. Yep.
How about Google Container Engine?
Yeah, how does Tectonic compare to Google Container Engine? Google Container Engine is a hosted product by Google Cloud Platform that runs Kubernetes. So you could run CoreOS and Kubernetes on top of Google Cloud, or you could run it on AWS or bare metal, but Google Container Engine will only run on Google Cloud. So Tectonic is something you can take between different environments, whereas GKE is something that is just a Google Cloud product. Yep. Yep.
Earlier, it was kind of a question was asked about Flannel and that it didn't do service discovery. Can you talk about how service discovery happened in Kubernetes with Flannel?
Sure. So this is one of the things about Kubernetes that is interesting and useful is actual service discovery is built in along with the scheduling. So once something lands on a host inside of your cluster, then you actually have a DNS endpoint that you can talk to or a load balance endpoint that you can talk to. So if we go into here, the concept of a service is a first-class object in Kubernetes. So in the example where I was hitting that this guestbook application, where I was hitting this guestbook application on this port, we can look in here and actually look at the guestbook service. And the guestbook service has this idea of a label selector where I can essentially wrap up all of the pods that match this service and then put them behind a load balancer. So there's 2 mechanisms essentially inside of, well, there's multiple mechanisms inside of Kubernetes. So you can use environment variables to get information on where services exist. You can use DNS, so you'll be able to query actually the guestbook, I forget the end of it, but just query the guestbook hostname and it'll actually resolve to the load balancer. And this load balancer is kind of a special IP address and port that exists throughout the cluster, but by default isn't routable from the external world. So, yep. Magic via load balancers is the short answer. All right, I think that's it. Thank you for coming by. Oh, and one last thing. I'm sure somebody's already said it here, but if you're interested in all this technology and we're going to work on it full time, coreos.com/careers. All right, thank you so much.